Dear students of class 12, my name is V. Ravishankar. I am a physics teacher in IIT Delhi, and what I am going to do in the next 7 or 8 lectures, we do not know how many, is to discuss the topics on the so called modern physics in your 12th standard physics course. So, essentially they will be chapters 11 to 13, and what we are going to cover are photoelectric effect, the de Broglie waves, Bohr model of the atom, and nuclear physics. This course is qualitatively different from whatever you have studied in your 11th and 12th standard. You covered a whole lot of courses. For example, you studied mechanics, both statics and dynamics. Then you studied electricity and magnetism, thermodynamics, optics, properties of matter. In all these topics, you were trained to solve a large number of problems, and some of them are quite intricate. This course is not exactly like that, because the mathematics that we are going to use is quite elementary. In fact, much more elementary than what you would use in, let us say, electromagnetism or mechanics or gravitation for that matter, rotational motion especially. But on the other hand, the concepts that we discuss are very, very deep. They are radical, so radical that at the beginning of the 20th century, last century, when great physicists like Hertz, Einstein, Millikan, name goes on and on, Lorentz, Bohr, Heisenberg, when these people encountered, they were completely startled. So, it does not mean that the subject is only conceptually difficult and mathematically easy. It is just that this particular course introduces to you the conceptual basis in a very simple way. But of course, after that, when you join for your graduation or post graduation in physics, you will start learning the mathematical aspects, the quantitative aspects, which actually is extraordinarily sophisticated. The other thing about the topics that we are going to study is that there are some fundamental issues on which great physicists even ponder about. For example, wave particle duality, what exactly does it mean? What exactly is the meaning of the uncertainty principle? What does one mean by measurement? These are the questions that we do not normally ponder about when we study classical mechanics. You were taught particle properties, you were taught wave properties, you did not have to worry. But here you do have to worry, because the same physical system can show or exhibit both particle nature and wave-like nature depending on the condition. So, there are lot of implications not only for physics, but also for metaphysics actually. Of course, we are not going to get into that. But the point that I am going to make here, or I am trying to make here, is that please do not take this lightly. In a certain sense, you can relax, because there will not be too much of mathematics. But in another sense, you have to be completely alert, because what we are going to discuss is really one of the most astounding achievements of humanity. We can very safely say that and proudly say that. So, with this brief introduction, it is actually good to announce our motto. What is the motto that we want to announce? We want to keep it simple, but we do not want to make it trivial, and this was very beautifully expressed by none other than the great Einstein, and you see that here in the next slide. So, it is good to announce what our motto is at this particular point, and what I am trying to say is that we are going to try to make things easy but not trivial, and this was very beautifully put by none other than the great Einstein, which you will see in the next slide. And if you look at this slide, he said, simplify as much as possible, but never oversimplify. Oversimplification gives rise to a feeling that you have understood something, or sometimes even everything, when actually it is not the case, and we shall try to follow this dictum. So, as I told you, this slide displays for you what are all the topics that I am going to cover. So, let me repeat so that it sort of gets fixed in your mind. The first topic that we are going to cover is photoelectric effect, and I am going to spend a lot of time discussing this effect, because not only do we have to write down the famous Einstein formula for the stopping potential or the ionization potential, we also have to describe the great experiments of Hertz and Mulliken very, very carefully, and also Lenard. I am going to spend a lot of time on that. And you should remember that Einstein got his Nobel Prize not for either his special theory of relativity or general theory of relativity, but for photoelectric effect. So, when you read photoelectric effect in your CBSE textbook or any other textbook, you may wonder, there is nothing much to do. Why is it that he was given a Nobel Prize? The answer to that came from Einstein himself. He said that creating special theory of relativity was a child's play comparing to obtaining an explanation, a proper description of the experimental results on photoelectric effect, because when it comes to relativity, he had the wisdom of 300 years of electromagnetic theory, Lorentz, Poincare and so forth, whereas when it came to photoelectric effect, he was charting his own course. So, that is something that we have to remember, and therefore